Alright, moving on to these ossification processes. So first I'm going to write something out that's kind of like a little template for both of these processes. Hold on. Alright, so what I hope to do here is I would recommend, if you can, get this little map. This is another mental map that I use to start getting these different things going on in your head for these ossification processes. So they're both going to occur in the same steps, the same stepwise fashion. We're just going to add different terminology and some different specifics between each. So we'll start with this intramembranous. Before I do that, I'll come over here. I always like to break these up into their roots if we can. So intra, what's the difference between intra and inter? Intra means within, while inter means between. So this isn't between membranes, this is within a membrane. What membrane are we talking about? This is just referring to our fibrous connective tissue. So now we have a starting material for intramembranous. That is our fibrous connective tissue, our FCT. So what I'm going to do is I'm going to talk through this all, and then I'll go ahead and draw a picture, and then we'll come back to the words and the picture simultaneously to wrap it all up. So you have the starting material, this fibrous connective tissue. Excuse me. Remember, fibrous connective tissue, since it's connective tissue, it has this mesenchymal origin coming from the mesoderm. We know nothing in the body happens without a signal. So for this case, with this intramembranous, we don't know exactly what the signal is. It's probably some accumulation of different proteins and whatnot that's going to kick off this process, but all we know is that it's a signal. So what's the signal going to do? It's going to cause osteoblast activity. So this signal is going to cause the accumulation of osteoblasts. I'm just going to do OB for osteoblasts. And it's going to accumulate at the center of ossification. Ossification is this bone-making process. Okay, so the signal is going to cause this accumulation of osteoblasts at the center of ossification. What do osteoblasts do? They divide. And they secrete matrix. Those are the two things they do. What is matrix? It's that background fluid and those proteoglycans making up the ground substance, as well as these fibers. So our osteoblasts have accumulated in this center of ossification. It's just a location within this sheet of fibrous connective tissue. We're creating this matrix. Remember, this matrix can be called matrix, it can be called osteoid, or it can be called osteoid seam. And then as more and more of this matrix is going to get deposited, we're going to start depositing those different salts, so like that calcium phosphate, those calcium and phosphate ions, and this tissue is going to start ossifying or getting hard or becoming bone. So this matrix is going to fill with calcium and phosphate. That's supposed to be charges. And phosphate, and it hardens, calcifies, whatever you want to say. So as a result of this, because we have this matrix filling up all this space, eventually we're going to get this isolation of some osteoblasts. So these osteoblasts are going to get isolated. When you get isolated from things, you're typically isolated from things like the blood supply, the blood connection. And if you remember, we've talked about this before, every cell needs a connection with the circulatory system for this exchange of nutrients and waste. So an isolated osteoblast is going to die. And it's going to leave space. Leave empty space. Alright, so these dead osteoblasts are replaced with hollow space, and then these, the hollow space can be filled with blood vessels, and that's where we'll get our red bone marrow. So there's two things that's going on. we have this spongy bone plus step. So spongy bone, when I think of spongy bone, I think of those trabecular plates that we talked about in the last video. And let me re-show you. I told you there's two different ways where we can get these plates and then these empty spaces. So in this case, when we're talking about intramembranous ossification, we saw how we got these trabecular plates because we're laying down this hydroxyapatite in the matrix that these osteoblasts are secreting. And then eventually we're going to get this isolation of osteoblasts and they're going to die. And when they die, they leave these spaces where we can make this red bone marrow. Alright, so in a quick recap, I just had to run and get my computer cord, so I want to make sure that I covered all my bases before we move on. So we're talking about the starting material as fibrous connective tissue. We get a signal which causes this accumulation of osteoblasts at the center of ossification. These osteoblasts are going to divide and secrete matrix. This matrix can be called osteoid or the osteoid seam. This matrix is going to ossify. It's going to get hard because we're getting this calcium and phosphate deposited into it. We get this isolation of these osteoblasts. They're going to die and leave hollow space. The space can be infiltrated with... Okay, so at this point, when we have the hardening of our matrix, that is what's giving us our trabecular plates. So the hardening of the matrix gives us our bone, our trabecular plates. These extra steps, whenever we have these dead osteoblasts leaving space, this space is going to be infiltrated with blood vessels. BV for blood vessels, and that's going to create red bone marrow. Okay, two more steps. So these osteoblasts secreting or surrounding this hardened matrix, they're going to differentiate into this periosteum. So we'll have osteoblasts are going to make this periosteum. Peri meaning surrounding, osteum being bone, so it's this layer of tissue surrounding the bone. And then our osteoclast activity. Osteoclasts do two things. They break down bone and they remodel bone from spongy bone into compact bone. That's one thing they do. And they also form and maintain medullary cavities. So with these kinds of bones doing intramembranous ossification, we don't have a medullary cavity, but we will get some remodeling from spongy into compact. And all that is we're going from this trabecular plate anatomy right here into this osteon functional unit anatomy for compact bones. Alright, so that's intramembranous. Let's draw a picture. So we're going to have this fibrous connective tissue starting material. And we're going to get, let's put some fibers in there. Okay, and we're going to get this accumulation of osteoblasts in something called the center of ossification. It doesn't actually mean the center of the cell, it's just the center of ossification. Don't quote me on it. I'm 99% sure, but there's still that 1% I could be wrong. I think you have multiple centers of ossification for this intramembranous, but let's just take a look at one to see what's happening. So you get the secretion of matrix. So the steps we've gone through so far, we have our starting material, this fibrous connective tissue. We have our signal, which leads to this accumulation of osteoblasts. And then we're going to divide and secrete matrix. So instead of dividing, I'll just say secretion of matrix for now. So here's our matrix being secreted. And then we'll eventually isolate. We'll say we'll isolate this top one I'm going around right now. Completely cut off from blood supply, so that thing's going to die. Boom, dead. I now have the surrounding purple. These have hardened, and this matrix has hardened and calcified from the deposit of these different ions. So that all this purple is now trabecular plates, and I can get this infiltration of the blood vessels, to make my red bone marrow. Alright, so I have my trabecular plates, I have my red bone marrow. That's the spongy bone plus steps part of this little schematic here, and then the last thing I need is osteoclast activity. So we'll get, if I did some more matrix around here, and this is all trabecular plates with these different hollow spaces that have become red bone marrow. So I just want to show some differentiation. And then the osteoblasts, this last step, we said these osteoblasts here on the outside, these are going to differentiate into our periosteum. So we'll just put this layer here. We'll now call this the periosteum. And then we're going to get this remodeling from compact into spongy. So we'll just change this color. These osteoclasts are going to come in and take those trabecular plate system, and it's going to change it into that osteon haversion canal system. So that's my picture. So what's a spongy bone going to look like at the end? Or sorry, what's a bone that's gone through intramembranous ossification going to look like? It's going to have this outside, call it a periosteum, this differentiated osteoblast. Deep to that, we're going to get this compact bone system made of these haversion canals and rings called lamella and all that stuff. Deep to that, we'll get some of these trabecular plates with these spaces, and there's a space, there's a space. These are really big spaces. And then we'd fill those spaces with red bone marrow. So in the end, we have around this periosteum, this tissue around this periosteum, this spongy bone around this periosteum gets converted by osteoclast into compact bone. Sweet. So that is intramembranous ossification.